Good morning, everyone, especially to you, Dr. Craig. My name is April Francis Rose J. Tinka, and I am the last reporter of our group. So my topic would be standard deviation. So let me first define what is standard deviation. So standard deviation is the positive square root of the variance. It is one of the basic methods of statistical analysis. Standard deviation is commonly abbreviated as ST and denoted by that symbol, and it tells about how much data values are deviated from the real value. Standard deviation is the degree of dispersion. Standard deviation is the degree of dispersion or the scatter of the data points relative to its mean, and descriptive statistics. It tells how the values are spread across the data sample, and it is the measure of the variation of data points from the mean. The standard deviation of a data set, sample, statistical population, and random variable or probability distribution is the square root of its variance. Okay, so we have this here. This was not stated in the handout, but to avoid confusion, because I was also confused in the handout because it was not explained there what is population, what is sample, but there is two types of standard deviation. So let me walk you through what is the two types of means, like the population mean versus sample mean. So here we have this illustration, population versus sample. So population, yes, is we have here the illustration of 12 swans, and here we have sample, we only have 5 swans. So what does it mean? Can you guess? Also, here we have another illustration. We have this total numbers of bees, and we only have 4 bees in a sample. So can you guess what population or sample is? Okay, so let's define population first. A population refers to an entire set of individuals or objects or data points that you want to study. It can be large or small depending on the scope of your research. So for example, all students in a school or all people in a country. That's a population. Another one, it provides a complete picture and is usually denoted by the big N. Okay? Right, so here we have another sample. Sample is a subset of the population. It's just a subset, it's like taken part from the population that is selected for analysis. It's used when studying the entire population is impractical or impossible because sampling allows for inferences about the population using statistical techniques. And for example, if the population is all students in a school, a sample could be 50 students randomly chosen from the different classes to participate in a survey. And it offers an estimate and is denoted by small n. So remember, population is denoted by the big N and sample is denoted by small n. Next, we have here these questions. When to use a population and when to use a sample. So when to use a population. Populations are used when your research question requires it or when you have access to data from every member of the population. Usually it is only straightforward to collect data from a whole population when it is small, accessible, and cooperative. Like for example, your population is your this one classroom, is one class which only has 30 students. That's the population. Then here we have when to use a sample. So when your population is large in size, geographically dispersed or difficult to contact, it is necessary to use a sample. With statistical analysis, you can use sample data to make your estimates or test hypotheses about population data. So like for example, you want to research in seated, but the population of seated is likely 1,000. So in order to contact those those respondents quickly, or time consuming, I guess, you have to use a sample because it is more easy and It is more accessible and cooperative and of course small. So the question here is, why take a sample? Mostly because it is easier and cheaper. Imagine you want to know what the whole university thinks. You can't ask thousands of people, so instead you ask maybe only 300 or 200. And Samuel Johnson once said, you don't have to eat the whole ox to know that the meat is tough, right? Right, okay. Now, let's talk about population standard deviation. There are actually two types of standard deviation. One is a population standard deviation and one is sample standard deviation. So let's dig deeper about population standard deviation. So it is a measure of dispersion for an entire population. It is calculated from this formula. As you can see, that is the formula. Yes. So to calculate the standard deviation of those numbers, we have here 4 steps. Step 1, work out the means, the simple average of the numbers, okay? Step 2, then for each number, subtract the mean and square the result. Step number 3, then work out the mean of those squared differences. And step 4, take the square root of that and we are done. Okay, so it might seem easy, but it's actually very, very hard. So let me take you through the formula explained. So example, Sam has 20 rose bushes. So the number of flowers on each bush is 9, 2, 5, 4, 12, 7, 8, 11, 9, 3, 7, 4, 12, 5, 4, then 9, 6, 9, 4. That's the number of flowers on each bush. And Sam has 20 rose bushes. Okay, so step 1, work out the mean. So this is the letter mu, the Greek letter mu, that is the mean, and yeah, that's the symbol. So example, it says here work out the mean. So all you have to do is to add these numbers and then you'll get 140. And then you're gonna divide it for the total of the population, which is 20 rose bushes. So 140 divided by 20, and then your mean would be 7. So that's how you get the mean. And then step 2, then for each number, subtract the mean and square the result. So basically you're just gonna substitute this, the x, and then variable number 1 minus mean squared. Okay, so example, 9 is the mean. Okay, 9 is the first value, 9 minus the mean, which is 7, and then square it. Okay, so 9 minus 7 equals 2, squared equals 4. And then you're gonna copy the same process up to the last variable. Okay, and we get the results for 25, 4, 9, 5, 0, 1, 16, 4, 16, 0, 9, 25, 4, 9, and 4, 1, 4, 9. That's the result. And then let's proceed to step 3. Then work out the mean of those square differences. To work out the mean, add all up the values, then divide by how many. So first we add them all up. But how do we say add them all up in mathematics? So we use sigma. The handy sigma notation says to sum as many terms as we want. So we want to add all the values from 1 to n. And n is 20 because the population is the big N. So it's 20, right? Right. And here is another example. So you have to sum all the values from variable 1 to variable 20. Okay, so we have this results. We have to add them all up. That is 178. Alright. Now we have to, as you can see, means of square differences equals 1 divided by 20. We have to substitute that. That is 1, and then n, the big N is 20 because that's the population of our example. Okay, 1 divided by 20, then times 178, and you will have 8.9, and that is the variance. Okay, so step 4, take the square root of that. So the population standard deviation would be 2.983. Kindly check if that's the answer. You just need to square root 8.9 and then you'll get 2.983. Is it right? Okay, so that would be the population standard deviation, or that's how you get the population standard deviation. Okay, now let's proceed to sample standard deviation. So the sample standard deviation is a measure of the amount of variation or dispersion in a set of values. It is calculated by the formula given. Yes. So let's take another example. So example, Sam has 20 rose bushes. That's the total population, but only counted the flowers on 6 of them. So we're talking about sample standard deviation here. So let's let's take out 6 bushes for the sample standard deviation. Okay, so let's say Sam's flower counts are 9, 2, 5, 4, 12, and 7. Yeah, 6, 6. But when we use the sample as an estimate of the whole population, the standard deviation formula changes. So here's a change. That would be our new formula for the sample standard deviation. So the important change is n minus 1 instead of n. Okay, because it was supposed to be 1 divided by n, but now in sample we use n minus 1. Okay, it's called Bessel's correction. So Bessel's correction refers to the n minus 1 found in several formulas, including the sample variance and sample standard variation formulas. And this correction is made to correct for the fact that these sample statistics tend to underestimate the actual parameters found in a population. So here we have step 1, work out the mean. Example 2, using sampled values 9, 2, 5, 4, 12, 7. So the mean we have to add it all up and then divide by the mean, by the sample mean, which is 6. And then here we have 9 plus 2 plus 5 plus 4 plus 12 plus 7 equals 39. 39 divided by 6, that is the mean, equals 6.5. Okay? That's a sample. Okay. Now we have to apply then for each number, subtract the means, and square the result, and then we have to apply it for the 6 variables, and that's it. Alright, and then we have to add it all up. Add it all up. That's right. And divided by n minus 1. And n minus 1. So that would be 13.1. That is called the sample variance. Okay, you have to add 0.5, 0.15, 6.5, 30.5 plus 0.5 equals 65.5 divided by n1. So what is n1? 6 minus 1, so 5. So 1 divided by 5 times 65.5 equals 13.1, and that is the sample variance. Okay, so to continue, you have to take the square root. So the square root of that is 3.619. So that is a sample standard deviation. It's easy, right? Okay, so now we're done with that, and let's go to comparing. So when we use the whole population, we got the mean, right? We got the mean, which is 7. And then standard deviation, which is 2.983. And then in sample, we got the sample mean for 6.5 and sample standard deviation of 3.619. So that means our sample mean was wrong by 7% and our sample standard deviation was wrong by 21%. So how do you know that? Like, how do you know that it is 7% and 21%? So here we have percentage error. Okay, so calculating the relative percent error. The relative percent error compares an experimental value to the correct or expected value, expressing the answer as the absolute value of a percentage. A relative percent error of 0% means that the experimental value is the same as the expected value. Okay? Here is the formula. So relative percent error equals true value minus experimental value divided by true value times 100. That's how you get it. Okay? So where true value is the expected or theoretical value, experimental value is the calculated value based on the data. So here, for example, a sample mean is here 6.5. The true value is 6.5 minus experimental value, which is the population mean. Okay, that's the experimental value. So 6.5 minus 7 divided by 7 times 100, then you'll get 7.14%. Okay, so that means the sample mean is about 7.14 below the population mean. Okay, and then here we have also the population. Okay, so here we have the true value, which is 3.619 minus 2983, which is the experimental value, and divided by the true value, 2.983, and then multiply it by 100, and then you'll get 21.34%. So the population standard deviation is about 21%. Sample standard deviation is about 21.34%. The sample standard deviation is about 21.34 higher than the population standard deviation. Alright, so let's now delve into the interpretation of standard deviation. So the standard deviation is simply the square root of the variance. The standard deviation is an especially useful measure of variability when the distribution is normal or approximately normal, because the proportion of the distribution within a given number of standard deviations from the mean can be calculated. It simply tells you how far numbers in a group are scattered from their average. It tells how the values are spread across a data sample, and it is a measure of the variation of the data points from the mean. Alright? So for example, here we have two bowlers, Katie and Mike, have the scores given below. Okay, does this mean they are equivalent bowlers? No. Consider the standard deviation. Katie has a standard deviation of 37.6470 and Mike has a standard deviation of 26.1017. So since Mike has a smaller standard deviation, he is more consistent bowler than Katie. So Mike is more likely to get a score of 200.4. So if you compute the mean for both set of scores, you get 201. Right? So Mike's scores indicate greater consistency than those of Kate. And this means that Mike tends to do better than Kate because his scores are more consistent than of Kate. So that would be all for my report. Thank you so much for listening and watching.